So this is the final video of this semester for Chapter 9. We talked about it briefly in the previous video, but what is the best way to make a prediction when there is no linear correlation? So provided a little information that was from the other notes about regression lines. We know Statcrunch has given us the output y equals b plus m times x. And so here's an example of one. This is your intercept. And this negative 3.787878 is the slope, or m. But that's the format that Statcrunch puts the prediction out. But what we want to address here is the correlation when x and y is not significant. The regression line cannot be used, so the mean of the y values, y bar, is used instead. And we're going to look at a problem where we get to see what this looks like. And remember, y bar is the mean of the y values. So you have some rules for predictions. When the correlation of x and y is significant, you use the equation and solve for y bar. When the correlation is not significant, I'm sorry, let me back up. When the correlation between x and y is significant, the best predicted y value is y hat. Substitute given x value into y hat equals b plus mx and solve for y hat. When the correlation between x and y is not significant, the best predicted y value is y bar. Y bar is the mean of the y values in the data. And remember what we learned in the last video, it's not meaningful to predict the value for y when the x value is outside of the range of the original data. In the scatter plot, an outlier is a point lying far away from the other data points. So the instructions for Statcrunch are still here. The example I'm going to use for this actually came out of the chapter notes. So let's get to the problem itself. So this is a case where the regression equation would not be appropriate because there's not going to be any linear correlation we're going to see. This case will be addressed in this example from the notes. So this is Old Faithful, supposedly erupts every hour, but actually it doesn't. So what they did, they collected some data, and so this is in seconds and this is in feet. And they wanted to see if the number of seconds in between eruptions, if the height of the eruption had anything to do with the time, the elapsed time between each eruption. So the interval after each of these are in seconds, and each of the height is in feet. So I'm gonna pull Statcrunch up and show you where I entered all this, and we're gonna run the thing in Statcrunch. But here's what we're gonna find. When we run Statcrunch on this, we get an R value of 0.269. Already I'm looking at this saying we don't have linear correlation. The critical R values from the table, and by the way, I've provided the table in this set of notes. It is on the last page. But so let's go down and see where that came from. We had 8 data sets and 0.707. I hope I didn't type that in wrong. No, that's exactly right. Plus or minus 0.707. So looking at that again, I went 8 pairs of data, 5% significance level. This 0.707 is my critical values. And remember, that's a plus or minus. So we'll go back. Now, remember my null hypothesis is rho equals 0, no linear correlation. The alternative hypothesis, rho is not equal to 0, some linear correlation. So we determine whether there's a significant linear correlation between the height of an eruption and the time interval after the eruption. Now, use alpha equals 0.05. I should probably put an extra 0 in there. So the test statistic using Statcrunch came in at 0.685. The p-value we see is pretty big, 0.5188. Well, we're just going to use the p-value to make our decision. The 0.5188 is greater than 0.05, so we're going to fail to reject. We fail to reject. We're saying there is no linear correlation. Now, Statcrunch will still give us a regression equation. And we can put that in there and we can calculate it, and we've done that here. And so y hat actually equals 86.3 seconds if you plug it into this regression equation. We're also going to do summary stats and get the sample mean for the y column, which is the y bar, and that's y equals 86. So which of these two is the better one? And this, I'm going to highlight this right now, I hope, is going to be the better. Well, hopefully I will. Let's try that again. There we go. So that's actually the better prediction because there was no linear correlation. So we predict how long the interval will be between eruptions. If the height is 130 feet, they said just take the mean. And the mean is, since there is not a linear correlation between the height of the eruption and the length of time between each eruption, the best predicted value of y is the sample mean, y equals 86. So here you see where I've got the data entered in Statcrunch, and I ran the summary stats, and there's my mean of 86 right there. So, and it says the summary tool within Statcrunch was used. And remember, all these pages that I'm speaking from for these videos, these notes are available. And I want you to use them during the test. This is an open book, open note test. So anyway, the summary stats tool within Statcrunch was used to compute the sample mean of the y column. Some of the questions will give you, so in other words, they may not make you go to this much trouble. They may actually give you y bar and y hat and p-values and test statistics and critical values and ask you to apply what you've learned to decide which one is the best prediction. Now that's just a hint about a question you might see. And so here is the screen capture from, there is my p-value, there's my test statistic, and I have a prediction of 86.3 when I plugged in that 130, so it's really not that far off in this case. In other cases, you'll see it can be quite far off. So before we leave, let's look at this in Statcrunch. There's the data. The first thing I'm going to do is regression, simple linear. I got my height as my x variable. And again, I put this, I had to enter the data, you notice in 2 columns. I'm going to put the 130 in because at this point, I don't know if I have a linear correlation or not. Well, I do. And there's how, whoops, don't want to pull me over there. There's how and right now, when I look at this p-value right here, 0.5188, I said, oh boy, we are definitely rejecting. There is no linear correlation. So I might as well go ahead and do, well, let's pull this over. I may go ahead and do summary stats, columns, and I want the y column, the interval in seconds, and there you see the 86 seconds. That is the mean, that is the best prediction for this particular problem. So let's put that away. So I've got screen captures here, and then I also have the Pearson ARB. So this might be useful when you take this last exam. This is the end of the new material. So when you guys finish, a lot of people have asked about the final exam. There is no final exam. You finish this test, make sure you do your exams, your student exam self-evaluation for every test that you've taken. You will be allowed to retake. Hopefully you won't need it. It's been a pleasure, and I will be in touch with several of you over the next few days. If not, have a safe summer, and I just be praying for you and your family during this difficult time.